So today we're going to be talking about our second factoring method, which is called the AC method. We use this method when we're dealing with trinomials, which just simply means polynomials that have three terms, right? The prefix tri means three, like in triangle, right? Three sides, three angles. So a trinomial is a polynomial that's got three terms. So when we have a polynomial that has three terms and we want to factor it, we will use the AC method. So let's jump on in. So really quick, before we jump into the AC method, let's just do a quick review of what you've learned so far about factoring, okay? So a quick factoring review. When you are asked to factor, remember, factoring means unmultiplying, okay? So you're taking something that's already been multiplied together and you're unmultiplying it. We're putting it back in the form of factors, okay? So your answer should be in the form of factor times factor. Now, whatever is in these parentheses will be different for each problem, right? It might be x plus 2 times x plus 4. It might be negative 3x plus 6 times negative 4x plus 8. Whatever is in those parentheses will depend on the problem. But when you are reading directions, and this is so important, you guys, you always have to be so aware of what you're being asked to do. So when you are reading the directions and you see the word factor, what I always tell my students to do is to circle that word factor and write right next to it factor times factor in the parentheses, just the way I have it here, right next to the directions. So that when you're done with the problem, when you go through and you factor it, when you're done with the problem, you should look at your answer, circle your answer, whatever you get, and then you go back and you look at the directions, and if your answer is not in this form, then you need to make it in this form. So sometimes when you get into doing problems, you forget what you're even trying to do in the first place. When you are asked to factor, you are being asked to give your answer in this form, factor times factor. So write that on your paper, whatever you're doing, next to the problem, so that when you get to what you think is your answer, you go back and you're like, oh, right, I needed to make sure that my answer was in the form of factor times factor, and you look at your answer, and if it's not in the form of factor times factor, then you need to figure out what you need to go back and do, right? Directions are so important. Am I being asked to simplify? Am I being asked to factor? Am I being asked to solve? We're going to be asked to do all these things in this class, and it's important to know what your answer should look like when you're being asked to simplify. What should my answer look like when I'm being asked to factor? And what should my answer look like when I'm being asked to solve? So when you're being asked to factor, your answer should look like this, okay? So, really important stuff. When factoring, always do the following. So when you're, again, think about directions. If the directions say factor blah, 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 factor this polynomial, okay, these are the steps you sort of should go through in your head. The first thing you should do is you should always check for an overall GCF first, okay? You should look at that polynomial, look at every single term, and say to yourself, is there a GCF in this overall term? Do the coefficients have something in common, and do the variables have something in common? And if there is, you pull that out. You factor it out right away, okay? So you always look for an overall GCF first before you go do factor by grouping or the AC method. The first question you should always ask yourself when you're being asked to factor is there a GCF, an overall GCF? And if there is, you factor it out. Now, this is so big. Most people will do that first step. They'll factor out their overall GCF, and then they'll go through and they'll either use factor by grouping or AC method or difference of squares, which we'll talk about in our next lecture, and to factor the rest of the polynomial, and they'll get their answer and they'll forget about that GCF that they factored out at the beginning. That GCF needs to be part of your final factorization. It's one of your factors, right? It's the greatest common factor. It's a piece of your factorization. So when you do factor out that overall GCF, you should like circle it, star it, put arrows next to it, like pointing down, so you do not forget to make it a part of your final answer. Okay, that's super important. So after you've looked for an overall GCF, that's always the first thing you should be doing. Is there a GCF? Is there a GCF? Is there a GCF? Okay, I found it, I've pulled it out, or maybe there's not an overall GCF. Then you move to the second step. The second step is to count the number of terms in your polynomial, because that's going to determine your factoring strategy, right? When there were 4 terms, we knew that we did factor by grouping, okay? If there's only 3 terms, if we're dealing with a trinomial, you will use the AC method to factor it, okay? And actually, if there's 2 terms, we'll talk about in our next lecture what method we would use for that. So first, you're looking for an overall GCF. Second, you're counting the number of terms, and based on how many terms are in that polynomial is the method you will use. So today we're going to be looking at trinomials, so we're going to, of course, be using the AC method because we're going to be looking at polynomials that have 3 terms. So where did the AC method come from? This is just like sort of a little bit of a review. The AC method is basically unfoiling, and hopefully that word foil should set off like something in your brain that you remember. Oh yeah, foiling. I sort of remember that now. Okay, so we're sort of working backwards from foiling. Okay, so when you foiled, you were actually given the factored form. So here we have, look, a factor times a factor, right, being multiplied together. And when you're asked to FOIL, you're actually multiplying those 2 factors together. You would do the firsts, the outers, the inners, and the lasts. That's where that FOIL comes from, right? So when you multiply all that out, when you multiply out your firsts, right, that's 2x times 5x, that gave you 10x squared. When you multiplied the outers, that was 2x times negative 8, which gave us negative 16x. When you multiplied the inners, that was 3 times 5x, which gave us 15x. And of course, when you multiplied the lasts, here they are, 3 times negative 8, and that gave us negative 24. Okay, and then you take all of these lovely answers that you just got. Let me circle that a little bit more nicely. There we go. And you put it together to sort of give you this new polynomial, right? So your 10x squared minus 16x plus 15x minus 24 minus 24. We can combine like terms. This is just like what we did in our review lectures, right? Adding polynomials. So negative 16x plus 15x, well, that just gives us a negative 1x. So when you simplified this whole thing down, you wound up with 10x squared minus x minus 24. So you started with the factors, okay, and then you ended with a polynomial. That was foiling. When we use the AC method, we're basically reversing that process. Now we're starting with this trinomial, and we need to get to the factored form. Okay, so we're undoing the FOIL. That's what we're doing when we're using the AC method. So this is where the AC method comes from, okay? So how do we use the AC method? What are the steps? Okay, it's important for you guys to understand that when we're dealing with a trinomial, a 3-term polynomial, okay, we, as mathematicians, write it like this. This is the general form of a trinomial. We write it as ax squared plus bx plus c, okay? And a, b, and c are our coefficients, our numbers. We know what coefficients are, right? We've gone over and over that at this point. So this is just the general form of a trinomial, okay? We have an x squared term, an x to the first term, and of course an x to the 0 term. And then we have our coefficients that are in front of those variables, a, b, and c. Okay, so those are just the numbers that are in front of our variables. We should feel pretty comfortable with that by now. Right, so that's the general form of a trinomial. So when we use the AC method, these are the steps we're going to take. The first step we're going to take is we're going to label our coefficients a, b, and c. Okay. The second thing we're going to do is we're going to multiply a times c. Okay. Whatever those numbers are, we'll multiply them together. The third thing we're going to do is we're going to find 2 factors of a times, we're going to find 2 factors, whatever we got for this answer of a times c, okay, whatever that answer was, we're going to find two factors of that answer that add to b, so our coefficient b. And that's the undoing of the foiling, okay? And the more you do this, the more you'll see how it's undoing foiling. And then, once we've found those factors, we're going to replace the b term with those factors. So now we'll wind up having a 4-term polynomial. And don't worry, right now just listen. If this is sounding like a lot in your head, we're going to go through examples in this video. So you will get to see how this actually plays out, and it will make a lot more sense when we're doing it. Right now, I'm just talking about it generally. So just listen for now. So now we'll have a 4-term polynomial, and we know that when we have 4 terms in a polynomial, what factoring method do we use? We use factor by grouping, okay? So we're basically going to take this trinomial and turn it into a 4-term polynomial so that we can use factor by grouping, because we know how to use factor by grouping. We know how to do that now. And we're going to use factor by grouping to finish factoring. But it's especially important to note that, remember, if there was an overall GCF, once we finish doing our factor by grouping, we cannot forget to include this in our final factorization, okay? So let's look at an example so that all of these words will start actually making some sense. Okay, so now let's look at an example of how we actually do this step by step, so it'll make a lot more sense when you actually see it done out and see the math. So this is our first example, okay? The directions would say something to the effect of factor or fully factor, and then it would give you a trinomial. So here we have factor x squared plus 6x plus 8. Now the very first thing that I am thinking is, okay, these directions are telling me I need to factor. So that means that my answer better be in the form of factor times factor. And guys, I literally tell my students, write that on your paper. Make sure that you know what the directions mean. That is a huge part of understanding math, okay? So write that next to the directions, right? Okay, factor times factor. So that way when you get to your answer, you go back and you make sure that your answer is in this form, factor times factor, okay? So remember, when you're factoring, the first question you should always ask yourself is there an overall GCF? And if there is, you should factor it out. So I'm looking at this trinomial, x squared plus 6x plus 8, and the first thing I look at is the coefficients. My coefficients are 1, 6, and 8. Do they share any factors? Well, no. Aside from 1, they don't. Okay? And then I look at my variable terms. I have x squared, x, and then my last term doesn't even have a variable in it. So they don't share a common coefficient. They don't share a common variable. So there's literally nothing I can pull out here. My GCF is just 1. Okay, so there's no overall GCF I can pull out of this, which means I can now move into my next step, which is count the number of terms. Okay, so when you're asked to factor, the first thing you want to do is check for an overall GCF, and the second thing you want to do is count the number of terms. I have 1, 2, 3 terms, which means we're going to be using the AC method, okay? If I had had 4 terms, I'd be using factor by grouping, but I have 3 terms. That tells me I need to use the AC method, all right? So the first step of the AC method is to label your coefficients A, B, and C. So what I've done is I've sort of rewritten my trinomial over here, okay? And I wanted to sort of highlight those coefficients so you could see them a little bit better visually. So my A here is actually this invisible 1, right? I didn't have a coefficient in front of my x squared term. Whenever I just have an x squared or a y squared or an x or a y with no number in front of it, there's just this invisible 1, right? Because 1 times x squared is x squared. So my A here is 1, all right? What's my B? It's 6, and my C is 8. So remember, those A, B, and C, they just stand for the coefficients, okay, of your terms, right? And your trinomial should always be written in descending order. If it's not, you should rearrange it so you don't mix up those A, B, and C's. Like if this had been 6x plus x squared plus 8, well, it's the same trinomial, but you'll notice that it's not in descending order, right? So you would have to rewrite it as x squared plus 6x plus 8 so that you label your a, b, and c correctly, because otherwise you would label it like this, a, b, and c, and your a would be 6, your b would be 1, and your c would be 8, and the AC method wouldn't work, okay? Your a, b, and c are the coefficients in front of your variables when it is written in descending order, okay? Highest degree to lowest degree. So that's important. So make sure if you need to, you rearrange your polynomial so that it is in descending order. But this one is given to us in descending order, so we can just label our a, b, and c pretty quickly. Now we need to multiply a times c. So let's do that, okay? Our a was 1, our c was 8, so 1 times 8 equals 8, okay? That's the first step. You multiply a times c. We need to find two factors of a times c that add to b. So let's take a look at that. When I do this step, you guys, I always draw a table. And on one side I put multiply, and I put my a times c. And on the other side I put add, and I put my b, okay? Because we are trying to find two factors of a times c that adds to b. Well, what is a times c? It's 8. We already figured that out. What's my b? It's 6. So we want two factors of 8 that add to 6, okay? So now I'm going to start on the left side of my table, and I'm going to list all the factors of 8. And I always just start with 1, you guys, okay? So 8 divided by 1, right? Well, that gives me 8. So my first pair of factors is going to be 1 and 8, because 1 times 8 is 8. Okay, and then I move to 2. Can we divide 8 by 2 evenly? Well, we can, right? 8 divided by 2 is 4. So my next pair of factors is going to be 2 and 4. And then I'd move to 3. Does 8 divide by 3? No, it doesn't. Does 8 divide by 4? It does, right? 8 divided by 4 is 2, but we already have that pairing, so we can stop, all right? Those are all the factors of 8. So remember, I'm looking for factors of a times c, so factors of 8, that add to b, that add to 6. So now I'm going to move over. Once I have all my factors, I can move over to the right side of my table where it says add, okay? So now I'm going to check each pair of factors to see if they add to 6. You might see it already, that's fine, okay? But we're going to do it all out the first time so you guys can see the example. So now I'm going to add together 1 plus 8, that equals 9, okay? Remember, I want it to add to 6. Does that add to 6? Well, no, it doesn't. So that pair of factors does not work. Let's try 2 and 4. 2 plus 4 is 6. Does that add to 6? Sure does. So this is the pair of factors that I wanted, okay? 2 and 4 are the pair of factors that I'm going to use in my next step. So now that I have those two factors, I'm going to replace the b term with those factors, okay? Which should sort of make sense, right? I wanted two factors of 8 that added to 6. Why? So I could replace that 6 with those two factors. So now I'm just taking my original polynomial, my original trinomial, and I'm rewriting it so that I'm replacing that 6 with the 2 and the 4 that I just found, okay? That's where that came from, because it's equivalent, you guys, right? 2x plus 4x, what does that equal? It equals 6x. So these are still equal. This polynomial and this polynomial are completely equivalent. X squared plus 6x plus 8 is the same thing as x squared plus 2x plus 4x plus 8, because 2x plus 4x is 6x, right? This is exactly the same, all right? So we're mathematically sound right now, okay? We haven't changed this in any way, but this is going to make it a lot easier for us to finish this factorization, because now I have 4 terms, okay? And I know that when I have a 4-term polynomial and I'm factoring, I use factor by grouping. So now we're going to use factor by grouping to finish this factorization, okay? So I obviously don't have enough room on this side to do that, so we're going to move on to the next slide so that you guys can see how to finish this off. All right, so let's move on down the slide. Okay, so now we've taken our two factors, 2 and 4, we've replaced our b term, our 6, with those two factors, right? Okay, so now you do factor by grouping to finish this factorization. And how do we do factor by grouping? When we split that polynomial right down the middle, so we have two terms on the right side, 2 terms on the left side, and we finish that factorization. So let's start with the left side. Okay, well, when we just look at the left side, okay, and we just sort of block this out for now. We'll deal with that in a minute. All I care about right now is the left side. X squared plus 2x. Well, now I'm going to factor that left side. So I ask myself, is there a GCF? Well, yes, there is, right? Both of these terms share x, okay? Did they have a common coefficient? No, because the coefficient here was 1, and the coefficient here was, of course, 2, all right? So they don't share any factors, but when we looked at the variable, we saw this x squared and this x. Remember, you always take the smallest of those, okay? They both share an x. So our GCF is now x. Okay, so now we're going to, of course, factor that x out of both terms. And when we do that, just factor it out just means divide by it, right? So now when we do x squared divided by x, we have 2 copies of x, we're dividing and taking one out. That just leaves us with an x on this side. And of course, these x's cancel completely, which leaves us with a 2 on in the other term. So when this factors, it factors as x times x plus 2, all right? So that's where that comes from, right? You always have to remember to include that GCF in your factorization. Don't forget that, okay? All right, so that was the left side. Now let's talk about the right side. So we're going to block the left side out, and now we're going to factor this side. So let's factor the right side, 4x plus 8. The first thing you're going to ask yourself, is there a GCF? If we look at the coefficients this time, 4 and 8, they do share a factor, right? They both can share the factor of 4. And then we look at the variables. Well, only the first term has a variable. The second term does not, so they do not share a variable in the GCF, okay? So our GCF here is just 4. Then again, we need to factor that out. That just means divide. Right? So we divide both of these terms by 4. 4 divided by 4, the 4's are going to cancel, leaves us with an x. 8 divided by 4 is going to leave us with a 2. So that leaves us with 4 times x plus 2. That's how the right side will factor, right? You can never forget your GCF when you're factoring. And then, of course, here's our x plus 2, and that's where that came from. Okay? So now that we've factored both sides, we can finish off our factor by grouping. That gives us this new almost completed factorization. We have x times x plus 2 plus 4 times x plus 2. We can look at that and say, oh my goodness, now is there a GCF that we can pull out of this? Well, there sure is, because both of those terms share x plus 2. So our new GCF is x plus 2. When we factor that out, remember, from both sides, remember, factor out just means divide. So let's divide both these terms by x plus 2. They cancel, and that leaves us with x plus 4 over here, right? All right, so that gives us a factorization of x plus 2. We can't forget that. And then, of course, x plus 4 when we factored everything out. All right, so that is the AC method. Now, guys, I know that seems like a lot of steps the first time you watch it through. Trust me, the more you do this, the faster it will become. So we will do one more example together. I'm going to go a little bit faster through the next example, and then you guys can try some on your own, all right? Okay, so let's look at our second example. I'm going to go a little bit faster through this one and not break it down quite as much, but we'll still go through each step together, okay? So remember, I see the directions. They say factor 2x squared minus x minus 6. I see the directions factor, and I think to myself, okay, my answer better be in the form of factor times factor when I'm finished with this, okay? So I write that down right next to my directions so that my brain knows to go back and check and make sure that when I'm done with this problem, my answer is in the form of factor times factor. Okay, so Now, the very first thing I always do is I check this for an overall GCF. Okay, so when I look at 2x squared minus x minus 6, I see that there is no overall GCF. The coefficients don't have anything in common. The variables don't have anything in common except for 1, of course. So I do sort of have a GCF. It's 1, but not anything that I'm going to pull out. So now my next step when I'm asked to factor, first I look for an overall GCF. Second, I count the number of terms. 1, 2, 3 terms, which means I am using factoring with the AC method, okay? So the first step of the AC method is to label my A, B, and C, my coefficients. Here, my A is 2, my B is -1, and my C is -6, okay? When you're labeling those coefficients, it's so important that you take the sign with them. So if you have a minus sign in front of one of the coefficients, it comes with it as a negative, all right? So now my second step to the AC method, I multiply A times C, which will give me 2 times -6, right? My A was 2, my C was -6. 2 times -6 is -12. The next step I'm going to do is draw my table because I need to find 2 factors of A times C that add to B. So on the left side of my table goes multiply, and guys, I do this every single time. I make a table. On the left side, I write multiply, A times C, and I write what that equals. And on the right side, I write add, and I write what my B equals. Because I need 2 factors of A times C, which is -12, that are going to add to B, which is -1. So I'm going to start on my left side, my multiply side, and I'm going to think of all the factors that I possibly can for -12. And I always just start with 1, right? -12 divided by 1 is -12. So my first set of factors is 1 and -12. Then I move to 2. And if you need to, you just grab your calculator and you just do this on your calculator. -12 divided by 2. That goes in evenly. -12 divided by 2 gives me, or excuse me, yes, -12 divided by 2 gives me -6. So my next set of factors is 2 and -6, okay? Now I'm going to go to 3. I've divided by 1, I've divided by 2, now let's divide by 3. -12 divided by 3, that gives me -4. So my next set of factors is 3 and -4. And I'd actually keep going, you guys. I'm going to stop here just for the sake of room, but I would keep going. Okay, does it divide by 5? No, it doesn't. Excuse me, does it divide by 4? Well, we know it does, right? Because we see this pair of factors here. So I could keep going. I could do 4, and now my negative is going to switch, right? That's going to give me -3. Okay, it doesn't divide by 5. It does divide by 6, and that's going to give me -2, blah, blah, blah. And we would get our last set of factors, which would be 12 and -1. Now, if you'll notice, when you're dealing with a negative AC, you're going to wind up with 2 sets of factors where the negative sign just sort of reverses. So my first set was 1, -12, and my last set is 12, -1. So the negative sign just sort of reversed, and that happened for every single pair, right? The negative sign just kind of reversed. So whenever you have a negative AC, that's what's going to happen, all right? You're going to get one list of factors, and then the negative and positive signs will reverse, and you'll get the second half of your factors. So now I need to go through and figure out which pair of factors adds to -1, okay? So I'm going to just start with my first pair here. Okay, 1, -12. Well, 1 plus -12 gives me -11. That does not add to -1. Let's go to my next pair of factors. 2 and -6. 2 plus -6 gives me -4. That does not add to -1. Okay, so that's not my pair that I'm looking for. Let's try 3 plus -4. 3 plus -4 does add to -1, so that is indeed the pair of numbers that I am looking for, okay? So I found my factors of 12 that added to -1, okay? Now I can move into my next step. I'm going to replace the B term with those factors, okay? So that will give me 4 terms so that I can do factor by grouping. So here's my original trinomial, 2x squared minus x minus 1. I threw that 1 in so that you could see that when I replace my B term, I'm replacing this -1 with 3x and -4x, and I got those factors right from my table, right? Those are the ones I was looking for. This polynomial and this polynomial are completely equivalent because 3x minus 4x is -1. So 2x squared minus x minus 6 is the same thing as 2x squared plus 3x minus 4x minus 6. Okay, they're completely equivalent. All right, so I can do that. It's mathematically sound. But the reason that I did that, why did I replace my b term with those two factors, right? Because I wanted to use factor by grouping. And when I replace it with my b term with those two factors, I now have 1, 2, 3, 4 terms. So now I can, of course, do factor by grouping, which I'll finish on the next page. So let's take a look at that. Okay, so now I've taken my trinomial, I've used the AC method to turn it into this new polynomial that's got 4 terms so that I can use factor by grouping, right? And we should be starting to get really comfortable with factor by grouping by now. If you're not, make sure you go back and do some more practice problems. So we do factor by grouping, we split it right down the middle. Now we have a left side and a right side. So I'm just going to completely ignore this right side so I can focus on the left side. I'm going to take that left side and factor it first. How do I do that? Same process, you guys. I ask myself, is there an overall GCF? Why, yes, there is. That GCF is x, right? Both of these terms share x and nothing else. So that's all they have in common. So that is my GCF. When I factor out that GCF, it leaves me with 2x plus 3, which gives me a final factorization of x times 2x plus 3. If you are not sure where I got this from, because I know I'm sort of speeding up the process now that we're doing more and more of these, what you are going to do is pause this video, take this polynomial right here and divide by the GCF, okay, and see what you get, okay? If you're still feeling uncomfortable with jumping straight from here to here, okay? So that is what I get when I factor the left side. Now I'm going to completely ignore the left side. I've factored it, and I'm going to focus on the right side, all right? I need to factor the right side, -4x minus 6. Same process. I'm going to ask myself, is there an overall GCF? Why, yes, there is. It is -2. Both of these terms share a factor of -2. So when I factor that out, I wind up with 2x plus 3. And when I write the factorization of that, I get -2 times 2x plus 3. Okay? And again, if you're not comfortable with jumping from here to here, then you need to pause the video, take this -4x minus 6 and divide each term by your GCF by -2, see what you get and do it out the long way, okay? So when I factored both sides, I can now put it all together back into a polynomial, which gives me x times 2x plus 3, right? That came right from here on the left. And then, of course, plus -2 times 2x plus 3, which came right from here, all right? So why did I do all that, guys? Because now, look, now this polynomial has a GCF, okay? And it should jump right out at you, guys. When you do the AC method and you get to this factor by grouping stage, and you factored both the left and the right side, the new GCF should be completely just obvious to you, right? It should jump right out that both of these terms share a 2x plus 3. Your new GCF should be incredibly obvious to you. So my new GCF is 2x plus 3, so I'm going to factor that out, okay, and write it in its new factored form. And when I do that, I'm left with x minus 2. And guys, when you get to this point right here and you're factoring out that new GCF, you can just see the new term, right? So or the new factor, excuse me. Our new factor was x minus 2. Well, it came right from here, x minus 2. Because when you take out the 2x plus, when you remove your GCF of 2x plus 3, they cancel, and you're just left with x minus 2, right? So that's where this is coming from, okay? You can see it. It becomes really obvious when you start doing more and more of these. There's the x minus 2, okay? So and of course we can never forget to put our GCF is always a factor when you're putting things in their factored forms, right? So that's where the other piece came from. Now that I finished this, I need to just say to myself, oh wait, at the beginning when I did this, was there an overall GCF? And if there is, I would have included it in this factorization. But we didn't have an overall GCF when we first started this problem, so we don't need to remember to go back and put it in. And I should, of course, be asking myself, when I'm done with this problem, is it in the form of factor times factor, right? Remember way back at the beginning of this problem, we wrote next to the directions factor times factor, and we said our answer should look like that. And yes, indeed it is. We have a factor being multiplied by a factor. So we did this problem correctly, okay? So that is the AC method. I know that seemed like a lot, pretty lengthy. My best suggestion to you is to just practice these problems. Do your homework. If you want more practice problems, I can give them to you. I think there's some in Blackboard right underneath this lecture. Okay, practice, practice, practice the AC method. I promise you, I know it looks intimidating now. The more you do this method, you are going to get so fast with it, okay? It just takes practice, and you're going to get into a rhythm with it. You're going to get into a really good rhythm with it, okay, as you go through those steps. And if you need to go back and rewatch the examples as many times as you need, that's the great part about taking a class online. You can go back and rewatch the lectures, use the PDF that I include in the lectures to take notes. So reach out if you have any questions. But first, before you reach out to me, you have to at least try. So you have to at least try to digest this, to practice it. If you're not understanding it, to go back, watch the lecture, take some notes, do it step by step along with the video. And if you're really still not getting it, then you reach out to me, okay? But you have to at least try it first, all right? So I'm wishing you all my best of luck. I know you guys can do it. You are totally capable of this. You've got it, right? So have fun. Good luck. I'll throw some more examples onto the next slide for you guys, all right? Bye. Okay, so here are 3 examples for you guys to try. Write these examples down on like a blank sheet of paper. Give yourself a blank sheet of paper for each one. Then go rewind the video and go back and try each of these, going through step by step. Pause the video for each step that I do in the examples. Pause the video and you do it for each of these examples, okay? So that way you sort of have like a guide to help you, all right? I know you can do it. You got this. All right, bye, guys.